Welcome, children. Now we'll begin with exercise 7.4 from the 11th question. So, now last time we had done up to question 10. So, now we begin with question 11, where I is equal to integral 1 upon 9x square plus 6x plus 5 into dx. Now, this is a quadratic term, right? Quadratic equation type of term it is, quadratic polynomial it is. Now, we can convert it in the format x square plus a square or x square minus a square or a square minus x square. We can convert it into that format. Now, we have terms as 9x square plus 6x plus 5 and dx. Now, if I want to form a whole square related to these terms, then I have to first know what should be my last term. तो लास्ट टर्म की जो फॉर्मूला है वी यूज इट एज मिड टर्म स्क्वायर अपॉन 4 into फर्स्ट टर्म. Middle term, what is our middle term? Middle term is 6x. Okay, so 6 into 6 upon 4 into first term. Your first term here is 9. Okay, first term is 9, so 4 into 9. Now take the table of 2, cancel the common factors. 2 2s are, 2 3s are, again 2 2s are and 2 3s are. So we have 3 into 3, that is 9 upon 9. 9 and 9 will also cancel, and finally we got it as 1. So if 9x square is the first term and 6x is the second term, then the last term must be 1. The last term must be 1. So now I take the term as integral 1 upon 9x square plus 6x plus 1 should be my last term that we have calculated over here at the side by side. Now this 5 which I had, I write it as 1 plus 4. 5, I split it up as 1 plus 4. This 1, I take it along with 9x square and 6x. So this gives me 3x plus 1 ka whole square. This bracket term gives me 3x plus 1 whole square, and plus this 4 I can write it as 2 ka whole square. So therefore I categorized my question as integral 1 upon x square plus a square type of term. So on the side I have written the formula integral 1 upon x square plus a square. So formula for such a term is 1 upon a into tan inverse of x upon a. This 1 upon a tan inverse of x upon a. If I compare my terms with this formula, my a is 2 and my x term is 3x plus 1. So this term I can write it as 1 upon a. So my a is 2. So 1 upon a into tan inverse of 3x plus 1. This is my x term. So tan inverse of x term upon a term. So my x term is 3x plus 1 and upon a term is 2. If my x term is not a simple x term, then I differentiate that x term with category of x term. So I differentiate 3x plus 1. If I differentiate 3x plus 1, differentiation of 1 is 0 and 3x ka differentiation is 3. Whatever answer I get after differentiating that term, that answer I have to write 1 upon that term. So therefore I have now 1 upon that differentiated term. The answer is 1 by 3. So 1 by 3 into 1 upon a term, that is 3 into 2 is 6. So I have 1 upon 6 into tan inverse of x upon a type of term and plus the constant of integration c. Now I go to the next question, that is question number 12. Question 12 is I is equal to integral 1 upon, and I have under root of a quadratic expression. The moment I see quadratic expression, that means I have to bring my question in the format a square minus x square, or x square minus a square, or x square plus a square. So, therefore, now I have the terms here 7 minus 6x minus x square. So, in the side, I calculate my last term. So, the last term formula is midterm square upon 4 into first term. So, middle term. So, my middle term is 6. So, I have 6 into 6 upon 4 into first term. The coefficient of x square is 1. So 4 into 1. Now I cancel the common factors. 2 2s are 2 3s are. Again 2 2s are 2 3s are. So that is coming 3 into 3, that is 9. So my last term should be 9. I don't have a 9 in my question here. So what do I do is I add 9 and I subtract 9. My last term has to be 9, but since I do not have a last term, I write add 9 and I subtract 9. Okay. Now 7 plus 9 gives me 16. 7 plus 9 gives me 16, and 16 can be written as square of 4. So I write 16 as square of 4, and now all these three terms, the last three terms, I remove a minus sign common outside, and in the bracket, since I removed the minus sign common, all the three minus signs are common outside, and all terms inside the bracket will become positive, and I write them in a proper order. I write it as x square, then plus 6x and plus 9. These terms which I have here, x square plus 6x plus 9, I write it as x plus 3 ka whole square, because I converted into a perfect square. So now this is a square plus 2ab plus b square. So I wrote it as x minus 3 ka whole square, and the 16 which I had, 7 plus 9, that is 16, which is 4 square. So therefore it is under root of, it belongs to the category under root of a square minus x square. So integral 1 upon under root of a squared minus x square. And if you have under root of a square minus x square, the formula to be applied would be sine inverse of x upon a. So I will compare this with my terms over here. Comparing gives me a is 4 and my x type of term is x plus 3. So I have sine inverse of x upon a category. So therefore my x term would be x plus 3, and upon my a term, that is a term, is 4. After that I have to differentiate my x term, because it is not a simple x term, no. So I have to differentiate this term x plus 3. 3 ka differentiation would be 0 and x ka differentiation would be 1. Whatever answer I get, I have to write 1 upon that answer. But since the answer turned out to be 1, 1 upon 1 there is no need to write, and therefore my answer is sine inverse of x plus 3 upon 4 and plus c. Now we go to the next question. I is equal to integral 1 upon under root of x minus 1 and x minus 2. So the two brackets, first initially I'll multiply the two brackets. So multiplying the two brackets gives me x into x, that is x square. Then I have minus 2x and minus x, that is minus 3x, and minus 1 multiplied by minus 2 is plus 2. So it turns out to be under root of x squared minus 3x and plus 2. This means it is a quadratic expression. Whenever I have a quadratic expression, whether the under root is there or the under root is not there, the quadratic expression must be always converted into the category x square plus a square, or x square minus a square, or a square minus x square. So I have to convert this into a whole square term. Okay, so I first find out the last term. The formula for last term is midterm square upon 4 into the first term. Middle term, my middle term is minus 3. Minus into minus is going to make plus. So I just write here 3 into 3. That is, middle term is 3 into 3 upon 4 into first term. The coefficient of x square is 1 here. So into 4 into 1. Okay, 4 into 1. So therefore, nothing cancels here as a common factor. So I have here 9 upon 4. I have here as 9 upon 4. Now, I is equal to integral 1 upon under root of 1 upon under root of this term which I have here is x square minus 3x plus 9 upon 4. I did not have, the last term turned out to be 9 upon 4, but I do not have a 9 upon 4 in my question. So what do? I add 9 upon 4 and I subtract 9 upon 4, and this plus 2 is already there in my question. So I just write plus 2. Now this x square minus 3x, which was already there, x square and minus 3x, I added 9 upon 4 as the last term. So this makes a trinomial which is going to create a perfect square. So therefore x square, so this is x, 9 upon 4 would be 3 upon 2. So therefore it would become x minus 3 upon 2 ka whole square. Now the term which is left out over here, that is minus 9 upon 4 and plus 2. I take LCM of both these terms, so it becomes minus 9 and plus 4 2s are 8. So minus 9 plus 8 and upon 4. So minus 9 plus 8 upon 4 will give me minus 1 upon 4. So therefore this term which I have, minus 9 by 4 and plus 2, I can finally simplify at the side, and that becomes minus 1 upon 4. So I have under root of x minus 3 upon 2 whole square minus 1 upon 4. This 1 upon 4 which I have can be written as 1 upon 2 ka whole square. So therefore we go to the next step. So it becomes I is equal to integral 1 upon under root of, it was already x minus 3 upon 2 ka whole square minus 1 upon 4, I wrote it as 1 upon 2 ka whole square, and therefore it becomes, the question becomes of the category integral 1 upon under root of x square minus a square. Whenever under root terms are there, outside we do not have a 1 upon a or 1 upon 2a type of term, right? Because under root term is present, under root is present. So if under root of x square minus a square, so what is the formula? I can compare it if I wish. It is of the formula is of the category integral 1 upon under root of x square minus a square into dx. This I can write it as log of modulus of x plus the same under root question, that is x square minus a square and plus c. This is the formula which we are going to follow over here in our question. So if I compare, it should be x square minus a square. If I compare it with x square minus a square, my x term type of term will be x minus 3 upon 2, and my a term on comparison is 1 upon 2. So now if it is of the category under root of x square minus a square, then I can write it as log of modulus of x plus, see the formula I have written it over here. The formula is log of modulus of x plus under root of x square minus a square. This is the formula. This under root term is the same question, you have to just copy it there. But x term, I have to realize what my x is. So in my question, my x term is x minus 3 by 2. So x minus 3 by 2 ka whole square, and so that means this is my x term. So if this is my x term, I will write it as log modulus of x term. X term is this first term. So x minus 3 upon 2. So comparison by formula, if you compare, this is my x term. So modulus of x minus 3 upon 2, my x term, plus my question term. So my original question term was x square minus 3x plus 2 ka under root. So therefore it is log of modulus of x plus the question term. तो therefore x यानी कि x minus 3, जब भी ऐसा x term is not a normal x term, you differentiate that x term. 3 upon 2 का differentiation will be 0 and x का differentiation would be 1. If you get an answer, I have to write 1 upon the answer. But since the answer of this term differentiation is 1, so 1 upon 1 I don't have to write, and therefore the answer is log of modulus of x minus 3 by 2 and plus under root of the question term. Now, next question which I have is question 14. Question 14 is I is equal to integral 1 upon under root of 8 plus 3x minus x square into dx. So, therefore, that is going to be integral 1 upon under root of. Now, see, if I take this as the last term, then I won't get my solution. Why? Because when I find out the last term by the formula midterm square upon 4 into first term, my middle term is 3. So 3 into 3 upon 4 into first term. First term is coefficient of x, which is 1. So therefore nothing cancels and answer is 9 upon 4. So my last term should be 9 upon 4, and I do not have a last term as 9 upon 4. It is given to me in my question as 8. So what do I do when I do not have a last term? I add my last term and I subtract it. So I added it over here plus 9 upon 4, and since I have taken minus sign common from the terms over here, I have, it was minus x square, I removed it out common, so it became plus x square. It was plus 3, I removed a minus sign common, so it will become inside the bracket minus 3. Now my last term should be always positive, so in the bracket I have plus 9 upon 3. But since you apply this minus sign over here, then it will become minus 9 by 4. So when I added 9 by 4, it was outside, and that subtracted 9 by 4 with, because that minus sign was common outside, inside the bracket it appears plus 9 upon 4. So this is a trinomial which is going to give me a perfect square, a whole square. So I have x square is a square of x, then my minus sign is there, the middle term is minus, so minus, and 9 upon 4 is there. 9 upon 4 can be written as 3 upon 2 ka whole square. So therefore I have this last trinomial is going to give me x minus 3 upon 2 ka whole square. X minus 3 upon 2 ka whole square. And this term here outside I had 8 plus 9 upon 4. 8 plus 9 upon 4. Take LCM. So 8 4s are 32. 32 plus 9. 32 plus 9 is going to be 41. 32 plus 9 is 41. So that is 41 upon 4. 41 is not a perfect square of any term. So I write it as root 41 ka whole square, and upon 4. 4 is 2 ka square. So I wrote root 41 upon 2 ka whole square. Root 41 upon 2 ka whole square. And minus, I have this x minus 3 upon 2 ka whole square. If I compare the formula, then the formula becomes of the category integral 1 upon under root of a square minus x square into dx. Integral under root 1 upon under root of a square minus x square. This formula is for sine inverse of x upon a. It is for sine inverse of x upon a. Now, compare our formula with the terms over here. It is under root of a square, because it is a constant term, minus the x type of binomial which you have over here. So therefore you will follow this formula which I have here. Now formula, according to the formula, it is sine inverse of x upon a. So x term here for me it is x minus 3 upon 2, and upon a term which I have here is under root of 41 upon 2. Now I try and check out first only before resolving more further. Sine inverse of x category upon a category. This x category term I differentiate it first. 3 upon 2 ka differentiation will be 0 and x ka differentiation will be 1. So in the beginning I have to write 1 upon the differentiated x term answer, that is 1 upon 1, so we need not write it. After this step, now I take LCM in the numerator. So x into this 2 term over here. So that will become 2x minus 3 upon 2 and under root of 41 upon 2. Upon 2 both the terms get cancelled and I have sine inverse of 2x minus 3 upon root of 41 and plus c. Do not confuse that because it is 2x minus 3 इसका differentiation answer 2 होगा तो मुझे 1 upon 2 लिखना पड़ेगा. No, this is a simplified version of your basic term over here. Your basic x term was x minus 3 upon 2 जिसका differentiation answer 1 था. तो that 1 upon 1 we wrote here. And after that आपने LCM लेके further simplify किया, तो that simplified version you have got it as 2x minus 3. So do not confuse with that differentiated answer over there. So that is going to be sine inverse of 2x minus 3 upon under root of 41. Now next, that is question number 15. I have integral 1 upon under root of x minus a into x minus b. Now I multiply the two brackets and segregate the x square term, x term and ab term. So when I multiply, I get x into x as x square. Then I get minus ax and minus bx, and minus into minus is plus ab. Minus ax minus bx, minus sign I remove out common, and therefore I get minus bracket के अंदर a plus b into x and plus ab into dx. Now I want to find the last term. तो लास्ट टर्म क्या होता है? मिडल टर्म का स्क्वायर, यानी कि a प्लस बी इंटू ए प्लस बी अपॉन 4 इंटू फर्स्ट टर्म. तो व्हाट इज माई लास्ट टर्म? माई लास्ट टर्म इज a प्लस बी का होल स्क्वायर अपॉन 4. तो a प्लस बी का होल स्क्वायर अपॉन 4 इज माई लास्ट टर्म, यानी कि आई कैन राइट इट एज a प्लस बी अपॉन 2 का फुल स्क्वायर. तो दिस इज माई लास्ट टर्म. आई डिड नॉट हैव, माई लास्ट टर्म वॉज ए बी. I did not have that term. So what do I do in such cases? I add the last term and I subtract the last term. So I added a plus b upon 2 whole square and I subtracted a plus b upon 2 ka whole square. Now these first three terms which I have over here, the first three terms, that is x square minus of this term and this, together will form this trinomial, together will form up a whole square. So that will be x square किसका square था? x का, and this is a plus b upon 2 का whole square, and middle term is minus. So the sign of the minus term over here it will be, so that is going to be x minus a plus b upon 2 का whole square and plus. Now ये जो term मेरे पास बचा है ab minus this a plus b whole square upon 2, I take LCM of the term. A plus b का whole square will become a square plus 2ab plus b square, and upon 2 का square will give me 4. When I cross multiply and take LCM, that will become 4 into 2 का square will be 4, 4ab, and this minus sign will be applied to the entire answer. So that is minus a square minus b square minus 2ab. So that became 4ab minus 2ab is plus 2ab, and minus a square minus b square and plus 2ab. that minus sign throughout the bracket, we remove it out, bracket constant. When we remove this bracket constant, that minus sign I'm going to remove it out constant. So that becomes a square plus b square and minus 2ab. That minus sign, when we bring out common, this becomes plus over here. That becomes plus term over here. Okay. So now that is a plus sign over here, and this is a minus b ka upon 2 ka whole square. So this, it belongs to the category under root of integral and 1 upon under root of x square plus a square category it belongs. And formula for 1 upon under root of x square plus a square is log modulus of x plus the under root question term, right? So comparison karu, to my x term is this, x minus of a plus b upon 2. So that is modulus of this term which I have over here, that is x minus a plus b upon 2. So this is my x term if I do the comparison. So log of modulus of x term plus under root of the question term. And what was my original question term? My original question term was under root of x minus a into x minus b. So हमेशा जब अंडर रूट यहाँ लिखते हो आंसर में, तो it should be exactly the question term, that is under root of x minus a into x minus b, and close the modulus sign and plus c. Now lastly we'll go to question number 16. Question number 16 is I is equal to integral 4x plus 1 upon under root of term into dx. Here we'll do a little new method which you have still now not done. So previous exercise you did such a thing, that was substitution method. So this question we are exactly going to do by like the method of the second exercise, the substitution method. Okay, हम जितने क्वेश्चंस यहाँ सॉल्व कर रहे थे उससे थोड़ा अलग है ये क्वेश्चन. इट इज़ लाइक योर सेकेंड एक्सरसाइज क्वेश्चन. सो अंडर रूट ऑफ आई हैड 2x स्क्वायर प्लस x माइनस 1. इट इज़ अ क्वाड्रेटिक टर्म, यस. तो व्हाट डू आई डू, दिस क्वाड्रेटिक टर्म अंडर रूट के अंदर जो है, दैट क्वाड्रेटिक टर्म आई टेक इट एज t. द क्वाड्रेटिक टर्म इन द अंडर रूट आई टेक इट एज t. नाउ डिफरेंशिएट. तो 2 is a constant, x square का differentiation will be, x square का differentiation will be 2x. तो 2 into 2x is 4x and plus x का differentiation is 1, and therefore I have 4x plus 1 into dx, and that is equal to dt. तो 4x plus 1 into dx is equal to dt. Now let me substitute back the terms. तो ये जो मेरे पास था 4x plus 1 into dx, तो that has turned out into dt, and it was 1 upon under root of this full thing I had taken it as t, no? So that is integral 1 upon and under root of t. Under root of t, and the numerator into dx has become equal to dt. So therefore never I integrate अंडर रूट टर्म, तो मैं उसको क्या करूँगी, अंडर रूट का मतलब है पावर इज हाफ. Power is half in the denominator. When I bring it to the numerator, power will become from plus half, it will become minus half, because वो denominator से numerator में आएगा तो sign change कर लेगा power. तो denominator में वो plus half था, when it comes to the numerator it will become minus half. तो integral t raised to minus half into dt. Integral t raised to minus half into dt. Now integrate that. इंटीग्रेशन करेंगे तो पावर इंक्रीज होता है. नाउ माइनस हाफ को हम प्लस 1 करेंगे, इंक्रीज बाय 1. तो व्हेन यू टेक एलसीएम इट इज माइनस 1 प्लस 2 एंड अपॉन 2, तो दैट विल बिकम 1 अपॉन 2. तो पावर शुड बिकम 1 अपॉन 2, एंड सेम पावर टर्म नीचे भी रखते हैं हम, तो दैट इज टी रेज टू हाफ अपॉन हाफ. दिस डिनोमिनेटर का डिनोमिनेटर गोज टू द न्यूमरेटर, तो दैट इज 2 into t raised to half. Power half मतलब under root, so that can be written as 2 into under root of t. Now t was not my original question. So in my original question I had taken 2x square plus x minus 3. This full term I had taken it as t. So therefore that is 2 into under root of 2x square plus x and minus 3. t की जगह पे t का वैल्यू हमने सब्सटीट्यूट कर दिया. तो therefore we resubstituted the value and therefore I got 2 into under root of that whole term and plus the constant of integration. So next time we'll meet further for the next further sums in the exercise. Till then, thank you children.